All right, guys, let's knock out this review. Number one, 3 to the 2x is 26. Anytime you need to find the exponent, and we're doing log both sides, you know what I'm doing though. I'm going to go with the ln both sides. So I'm also going to go ahead and do this 3 squared just because I can. So I'm going to put the x in the front to make it natural log 9 because that's what 3 squared is, equals 26. You don't have to do that if you don't want to. So to finish up, I'm going to go to natural log 26 divided by natural log 9, see what I get. And it's like 1.4828 right there. Number two, a little bit longer here because it's got x on both sides. So same steps though. Gonna put the exponent in the front, x natural log 7. And of course you can also use LOG if you want to. Natural log 9. First step here is I need to distribute this natural log 9 through there. So I'm going to x natural log 9 minus 1 natural log 9. Gotta get my x's together, so I'm taking the x natural log 9 to the left-hand side equals natural log 9 over there. Take out the x, and if I take out that x, factor it out, that will leave in natural log 7 minus natural log 9, which is, by the way, 7/9, because remember subtraction means division. So I'm going to end up right here. I'm going to end up with negative natural log 9 over natural log 7/9. That's what I'm punching in. And it looks like I'm getting 8.7429. So there's 1 and 2. They're a little bit different than these other ones. Okay, number 3. Going to factor number 3. Using e to the x minus 2 and e to the x minus 1, which means my solution, that means e to the x must be 2 or e to the x must be 1. So to solve that, to make that e disappear, I'm going to do natural log both sides, which means obviously put the exponent in the front. So I got x natural log e equals 1 over here. Natural log e is really just 1, so it cancels. Natural log 2, if you punch that in, you're getting 0.6931. That's gone. So it should be natural log 1 right there. Sorry about that. Let me try that again. Natural log 1, there we go. Anytime this number right here is 1, that's basically saying to what power would you raise a base to get 1? The answer is 0 right there, so 0 power. Sorry about that. Number 4. Only has 1 log. Every time you see 1 log, we're doing the finger thing. Remember the base is e. We're going e to the 5.4 equals x. So let's say e to the 5.4 equals x. Just going to punch that in right there. E to the 5.4. I'm getting 221.4064. Keep rolling. Number 5. Still 1 log on number 5 also. So I'm going to do 2 to the 5th equals that. So 2 to the 5th equals x minus 4. Now 2 to the 5th is 32. So if I just move that 4 over, I'm going to get 36. Now one thing you need to be doing here, and I haven't been saying, is when you have a log, remember your log must be positive. So make sure whatever answer you get keeps your log positive. Number 6, I'm going to see 2 logs added together. You can never add logs. Remember that means you multiply. So I'm going to multiply x squared plus x equals log 20. And because there's 1 log on each side, you can just drop those, make it x squared plus x equals 20. Let's move that 20 to the other side so we can factor. And I'll factor with x plus 5, x minus 4, which gives me 2 solutions, maybe negative 5 and positive 4. However, negative 5 makes that negative, so that can't work. 4 looks good. Circle the 4. Number 7 also has 2 logs that are added together. So I'm going to multiply those 2 by doing FOIL. If I do FOIL here, it's base 9, don't forget. I'm going to get x squared minus 2x minus 15. That's what you get if you do your FOIL method. So because there's 1 log, I'm going to do the finger thing again. I'm going to 9 to that power equals that. So 9 to the first power is really just 9. I'm going to move that 9 over so I can factor. X squared minus 2x minus 24 is 0. Factor that with minus 6 and plus 4, which gives me a positive 6 and a negative 4. Plug those in and make sure negative 4 does not work. 6 does work. Now, don't think just because it's negative it doesn't work. That's not the deal. If it makes the log negative, that means it doesn't work. Number 8, suppose you invest $55,000 in an account that pays 6% interest per year. Compounded monthly, that's a big deal. It's not pert. How long will it take for it to double? Okay, so if it doubles, it's going to be worth $110,000. And the initial is $55,000. That's our principal. 1 plus R, the rate is 0.06. Compounded monthly. And it's NT power, so 12T. I'm looking for the T. So first thing I'm going to do is divide by the 55,000. That's going to give me 2. At the same time, I'm going to add what's inside my parentheses. 1 plus 0.06 divided by 12. I'm getting 1.005. So in one step, it's simplified a whole lot. And then that's right back to the very first question in this test. I'm going to do natural log both sides. I'm going to natural log 2 equals 12t. Natural log 1.005. Kind of out of room here, but I'm going to divide both sides by that natural log 1.005. So on my calculator right now, I'm going natural log 2 divided by natural log 1.005. Getting an answer, then because that 12 is still there, I'm dividing that by 12. That answer by 12, I'm getting 11.6 years to double that money. All right, number 9. Under ideal conditions, a certain bacteria doubles every 6 hours. Initially, there are 500 bacteria in a colony. There's our formula right here. Okay, and part 8, it says find a model. So I'm going to say N of T. Remember, find a model, leave the T in. The initial amount was 500. It doubles every 6 hours. Remember, A is the doubling time. So I'm going to put T over 6. That's your model. Part B says, how much will you have after 12 hours? I'm just going to plug in 12 for that T. So no 500 times 2 raised to the 12 divided by 6, which is really just 2, just squaring it. So I get 2,000. And then it says when we'll reach 8,000. So I'm going 8,000 is the final amount, 2,000 is the initial amount, e to the t over 6 power. Divide by the 2,000 first. So I get 4 equals e to the t over 6. Do a natural log each side. Natural log 4 equals t over 6. Natural log e. Natural log e obviously is gone. So what I'm doing on my calculator right now to get my answers, I'm going to punch in natural log 4 times the 6, because the 6 is in my denominator, and I'm getting 8.3 hours. With time, we can just go one decimal place, that's fine. Number 10, a similar type question. Initial bacteria count is 1,000. A biologist later makes a sample count. The culture finds risks of growth, so 50% per hour. Find the part A, find the function. So same deal. Part A, N of T, the initial amount was 1,000. E, growth rate's 50%, that's 0.5 times T. Okay, there's part A. Part B, estimate after 20 hours. So I'm going to put 20 in for the time. 1,000 e to the 0.5 times 20, which gives me a lot of bacteria. 22, 2, 2, 6, 4, 6, 5. That's a lot of bacteria. And then part C, how long will it take to reach 40,000? So I got 40,000 as my final amount. Initial amount was only 1,000. E to the 0.5 t. Divide by 1,000 first, you get 40. E to the 0.5 t, same old steps. Natural log 40. Over here, 0.5 t, natural log e. So I'm basically, to get my answer here for part C, I'm going to do natural log 40 divided by the 0.5, which gives me 7.4 hours to get that much. Number 11, one more of these things. Polonium-210 has a half-life of 140 days. Suppose that this substance has a mass of 600 milligrams. That's our initial. And there's our formula. Part A, also, Jerry wants to do both formulas here. So part A, we're going to do this one right here. So I'm going to do the M of T. The initial amount is 600. I have a 2. Negative T, I don't know the T, over the half-life, which was 140 days. All right, part B, I'm going M of T equals E. That's a misprint. This is what you should be using down here. So I'm going 600 E R. You got to find R. Don't forget what R is. R, I'm going natural log 2 over the half-life, which is 600. So I'm going to push that in first. Natural log 2 divided by the 600. And I'm getting 0.0012. Should be negative. And that's times T, not divided by T. That's a typo. Watch that on your test tomorrow. It may be on there too. C, find the mass remaining after 1 year. So the time is just 1. I'm going to use, just for time's sake, I'm going to use that second one right here. So I'm punching in 600 E, and because T is just 1, I'm doing E to the negative 0.0012. And I'm getting 599.28, which, basically 600. And then part D, how long will it take for it to get down to 100? So it's going to end up with 100. You're starting with 600. I'm gonna use the same one again, e to the negative 0.0012t. So if I divide by 600, I get 1/6 over here. E to the negative 0.0012t. Gotta move this up a little bit. All right, again, natural log both sides, negative 0.0012t, natural log e. Natural log e, they are gone. So to get my final answer, I'm doing natural log of 1/6 divided by negative 0.0012. And I'm getting 1493.1 days. It's a lot of days. All right, 12. Find the first 5 terms of this one, of the recursive. Okay, so they're telling you A1 is 3. That's a big deal. That's the first term. The second term, remember, recursive, you use your previous term. This right here, the A minus 1 is previous term. So I'm doing 8 times the previous term, which in this case is 3, because I'm trying to find the second term, minus 2. 8 times 3 is 24, minus 2, 22. So to find the third term, I'm going to do 8 times the previous term, minus 2. So 8 times 22 minus 2. I'm getting 174. The fourth term, same deal. Fourth term is 8 times the previous term, minus 2. 8 times 174, minus 2. I'm getting 1390. And then the fifth term. Fifth term, 8 times the previous term, minus 2, which would be 8 times 1390, minus 2. 11118. There's the first 5. Number 13, find the nth term of a sequence. You got to find the formula. All right, so first of all, I'm looking at the numerator. It's going up by 1, and it starts with 3. So if I just do n plus 2, think about that. If I put a 1 in there, I get 3. 2 in there, I get 4. 3, I get, that works perfect. On the bottom, it's doubling. That's really, think about it. That's 2 to the first, 2 to the second, 2 to the third. So on the bottom, it's going to put 2 to the n, and that's it. Number 14, 2 more. Find the first 4 terms in the 100 term of that sequence. So the first 4, all you do here is you plug in 1. It should be 1 squared plus 1, which is 2. To get the second term, you're plugging in 2. 2 squared plus 1, 5. Third term, 3 squared plus 1, 10. There's a pattern developing. Fourth term, 4 squared plus 1, 17. And the pattern is it's increasing. It goes up by 3, by 5, by 7. So the 100 term, you won't believe it, you're actually going to plug in 100. 100 squared plus 1 should give you 10,001. Last one, 15. Graph that function. Should be good at this by now. First of all, it's got an x plus 2 inside, which means it shifts it left 2. So your asymptote's going to be back 2. Maybe your first point's always 1 to the right there. And remember, we want this parentheses to equal whatever the base is. Well, the base is 3, so I want that parentheses to be 3. So I'm going to put 1 in for x. If I put 1 in for x, that gives me log 3, which really equals 1. So it means I plugged in 1, I got 1, right there, 1, 1. Connect the dots, la, 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 just like that. Your domain now goes from -2 to infinity. Your range is up and down forever. And your asymptote is going to be x equals -2. And there you have it. Hope that helps. Make 100, and then enjoy spring break. All right, see you tomorrow.